Okay, guys. So today, guys, we are going to introduce radical. Okay, radical, guys. We are going to talk about radical right now. But before that, I wanna recall you about exponent. I just wanna recall you about the definition of exponent. Okay. So of course, you know that the exponent shows how many times that the base gonna be used as a factor. Okay, exponent shows how many times that the base gonna be used as a factor. Let's say 2 square gonna be 2 multiplied by 2. That means the base, which is 2. Oh, let's go with another one. Let's say 3 square instead. So to not, I don't want you to be confused about it. So 3 square, that means the exponent is 2. The exponent is 2. It tells me how many times that the base 3 gonna be used as a factor. This is exactly the definition for exponent. So you guys understand that. So right now, guys, we gonna talk about radical a little bit. We gonna talk about radical. But before talking about radical, so well, let me give you an explanation real quick about this. This is the symbol for the radical. This is the radical symbol. Okay, this symbol, guys, is the symbol. So we find like over here, we got like the index. We got the index over here, the index, and right here we got the radicand. So the index will be over here, right here, and in front of the radical symbol we got the index. And after that, like under this one, under the radical symbol, guys, so we'll got the radicand. Okay, this is the radicand. So this is the radical symbol. Okay, so right now, guys, let's go back to our things. Let's talk about exponent a little bit. I told you that exponent, okay, just show you how many times that the base is gonna be used as a factor. Okay, so right now I introduce that, guys, in order to talk about like a perfect square. I just want to talk about perfect square, but this is the reason why I introduced the exponent. Okay, so you know that a perfect square, guys, this is a number, let's say a number or a variable that is the product of two identical radical rational factor. Let's say 3 times 3, it's a 9. Okay, can we say that 9 is a perfect square? Okay, starting from this definition, like a perfect square is what? Like a perfect square, guys, is a number or a variable. It can be a variable too. Let's say x squared equal x multiplied by x. So it can be a variable too. Okay, a number or a variable that is the product. That is the product. Product is the result from the multiplication. That is the product. You see 3 multiplied by 3, the answer is 9. I mean 9 is the product of two three identical, three, they are the same, right? The identical two numbers, identical rational factors. Three, they are rational numbers, right? So exactly, this is the definition for perfect square. So whenever that you got two numbers, Okay, you got a numbers. Let's say whenever we got a numbers, okay, or variable, so okay, that is the product of two identical rational number. We call them we call them perfect, perfect, perfect square, perfect, perfect square, perfect square. Okay, we call them perfect square. Okay, this is how we call them, perfect square. A perfect square is a number or variable that is the product of two identical rational number. Let's say by example 25 is 25 is 25 a perfect square? Let's see by definition. Okay, let's see by definition. I know perfect square is a number. Okay, is a number. This is a number. Okay, or variable too, but in this case, this is a number. Okay, this is a number. Okay, where the okay where the product, okay, well, or this is a number, let's say this is a number or variable that is the product of two identical rational numbers. So let's see if I can find two numbers identical when I multiply them, so I can get 25. Let's say I know 5 by 5 give me 25. That means 25 is a perfect square since it is the product of two identical rational number. So this is a perfect square. So with that, guys, I know that you can easily identify the perfect square since you know the definition for perfect square. So right now, guys, you already know about this one. So fill this let's fill this table out real quick. So we just gotta identify over here and what is the index over here. So let me tell you guys, when you see a radical symbol right here like that, you don't see anything over here. That means automatically the index is a 2. Okay, and the radicand is the 4 because the radicand is the number under this one. This is the 4. And how we read this? We read this the square root of 4. You said square the square root of 4. Okay, this is how you read this one. So let's go for this one. The index is a 3. The radicand is a 8. Okay, we read this the cube root of 8. Okay, so let's go for this one. So we got 4, which is the index, 81, which is the radicand. So guys, let me know how can I read this in the comment. Let me know how can I read this in the comment. Okay, so exactly. So let's go for right now for perfect cube. We don't have only perfect square, but we have perfect cube. This is gonna be the same, but this time it should be three numbers. That means a perfect cube is the product of three numbers, three identical rational numbers. That's it. This is gonna be a perfect cube. Like let's take that example. Let's say 8 is a perfect cube because 2 multiplied by 2 multiplied by 2 equal 8. That means a perfect cube is the product of 2. The product, this is a number. A perfect cube is a number that the product that a perfect cube is a number, okay, or variable that is the product of three identical rational number. Okay, identical rational number. This is the definition for perfect cube. Okay, perfect cube. So guys, we just started the journey with radical. We got a lot to see in radical, but I want you guys to know the basics. You know the symbol, you can identify the symbol, you know where the index is, you know where the radicand is, and you can read them easily, and you know the difference between perfect square and perfect cube. So this is the reason why I bring up this we call on exponent, because I want you to understand that exponent was like that. So we got, okay, it's like the number of times that you know what I mean, with the number of times that the exponent gonna be used as a factor. So exactly, you see three, I mean this one gonna be written like this. So we see 3 multiplied by 3, it's like multiply the base by itself as many times the exponent tells us to do it. Okay, this is how it works. So I do this recall in order to bring up the perfect square and perfect cube for you, so you can understand it. Okay, so you can understand it. So I don't know, guys, if you don't understand. If you don't understand, or if you got question, let me know in the comment, because we're gonna move on. We're gonna move on, guys. With what? We're gonna move on with fractional exponent. Okay, we're gonna move on with fractional exponent. So, but before that, guys, I want you to be able to identify the index, the radicand, and to be able to read it, to know the perfect square, to know the perfect cube, and to know how to identify them. So that means you know the definition of them. Okay? Easy stuff, guys. Nothing difficult at all. Nothing difficult. Let me know if you got a question. Okay, guys, so let's move on with fractional exponent. So fractional exponent, this is another way, guys, to express a radical without the radical symbol. This is another way to express, okay, a radical without the radical symbol. Oh, this is this all the way that you finna study. Okay, so let's go. How you do that? It's like you got this one, guys. It's gonna be like this. This one, guys, is gonna be like this. Y exponent rot 4 over 2. Okay, 4 over 2. Okay, y exponent 4 over 2. This is exactly how you will write this. That means the index over here, since you don't see nothing, it's a 2. You see the square root. So this is a 2. The 2 is gonna be what? It's gonna be the exponent denominator. The 2 is gonna be the index is gonna be the exponent denominator, and the exponent of the radicand is gonna be the exponent numerator. It's gonna be the exponent numerator. Okay, so let me tell you, to do that, to express the radical without a radical symbol, okay, you just gotta say the index guy gonna be the index gonna be the what? The index gonna be the exponent denominator, okay, and the radicand exponent, the radicand exponent the radicand exponent gonna be is going to be the exponent's numerator. You see what I mean? That means if I got this, okay, radical to write as a fractional exponent, it's gonna be like that. That means the radicand is gonna be, you put the radicand over here, and the exponent, you will put the index, gonna be the denominator, and the radicand exponent is gonna be the numerator. Okay? So easy stuff. Easy stuff, guys. So in general, I can say any radical can be expressed as a fractional exponent. In general, any radical can be expressed as a fractional exponent. Any. Okay, you just gotta use the index as a denominator and the radicand exponent as the numerator. Only that you can do. Only things you gotta do. Okay, so nothing difficult at all, guys. Nothing difficult at all. So let's go for this one. So what we gonna do? We gonna follow the steps. First of all, we write them, okay, as a fractional exponent. It's gonna be x, okay, the index gonna be the exponent denominator. Here's the index, it's gonna be the exponent denominator, and the exponent of the radicand is gonna be the numerator. So that means this is the fractional exponent form of, okay, the cube root of x cubed. Okay, this is exactly how we do it. So guys, easy stuff. So I want you guys to practice with that. Okay, I want you guys to practice with that a little bit for me. Practice with that, please, guys. I want you to give me the answer in the comment. I mean, put this using the fractional exponent instead, because I don't want to see the radical exponent over here. So go ahead, guys. Go ahead, practice on this. And if you got questions, let me know in the comment section. Okay? Don't be afraid to ask questions. So don't be afraid, guys, to ask questions.